Pacing is other method of measuring the distance by simply having pace factor. This method will only require the student to walk on the preferred distance by their natural walk from one point to another. By doing this king of method, it will give you the distance but not as accurate as other because it will depend on the person doing the field work. Distance by pacing are sufficiently accurate for small-scale mapping, for locating details, and traversing with the plane table and the reconnaissance surveys. It is also used for many purposes in geology, forestry, engineering, and agriculture. Under average condition, a good pacer will have little difficulty in pacing distance, with a relative precision of 1/200. Result could be attained with 1% of accurately measured distance. Unless a mistake has been made in counting, it will seldom be more than 3% in error.
Objectives. There are two objectives in this fieldwork. The student shall be able to first gain individual pace factor. Students will walk from one point to another with known and measured distance. And second, test the accuracy of the pace factor of the students in pacing out a given distance. Students will walk from one point to another with unknown and unmeasured distance.
Next, instruments. The way used for pacing. First, range pole. Range pole are used for sighting points for lining up the person in order to keep them going in the right direction. Second, chalk. Chalk is used for making the ends of tips at intermediate points while pacing. Third, 50-meter tape. 50-meter tape is a flexible roller used for measuring the course length from one end of the tape to the other end.
Procedures. For the first part of the fieldwork, the determination of individual pace factor. The following procedures are: first, the students will measure at least 30 meters line using a tape on a level ground. Second, the ends of the assigned line are marked with either hubs or marking pins or by chalk marks. Designate the endpoints as A and B. Third, set or hold range pulls behind points A and B or outside the line AB. These pulls will aid the students to travel in a straight path. Fourth, each student will be pacing the line from A to B, starting with heel or 2 over A, keeping their eyes focused on the range pull behind point B to keep themselves on the straight path. One has to walk in their natural unaffected manner and has to keep counting their number of paces for the entire course being covered. A partial pace at the end of the course should be figured out to the nearest 1/4 of a pace. Record this as the number of paces for trial number 1. Fifth, for trial number 2, each student should walk from B to A in the same manner as in the first trial. Sixth, repeat steps 4 and 5 to comply with the number of trials required by the instructor, or minimum number of trials is equals to 5. And seventh, data should be entered in the preliminary data sheet. For the second part of the fieldwork, the determination of an unknown distance of the assigned line through pacing, the following procedures are: first, the instructor will mark another points C and D with unknown length to be paced by each student. Second, range pulls are to be set outside the level course to straighten the path of the student. Third, each student paces the course with a minimum number of trials as required, recording the number of paces for each trial, or minimum number of trials is equals to 5. And lastly, fourth, After all field notes are recorded, the students will make an actual taping of the line CD to determine its actual measured distance.
So for our calculations, so first, we have a given tape distance length AB is equal to 30 meters. So we have performed 5 trials on the line AB, and we have accumulated a number of paces. So for trial 1, 47 paces. Trial 2, 49 paces. Trial 3 is 47 paces. Trial 4 is 47 paces. And trial 5 is 47 paces. So we can calculate now the mean number of paces. So it's just the sum of all paces divided by the total number of trials. So mean is equals to 47 plus 49 plus 47 plus 47 plus 47 divided by the total number of trials, which is 5. So mean number of paces is equals to 237 divided by 5. So our mean number of paces is equals to 47.4 paces. Now we have our mean number of paces, and we have a length of our line AB. So we can calculate the pace factor. So pace factor is just equal to length divided by the mean number of paces. So pace factor is equals to 30 meters divided by 47.4 meters per paces. 47.4 pace. So pace factor is equals to 0.6329 meter per pace. So after getting our pace factor here, so we can calculate the second problem, which is measuring distance by pacing. So we have a pace factor, and we have the number of paces. So we can calculate the mean number of paces and multiply it to our previous pace factor to get the L pace. So what is our measured distance here? So the measured distance is 38.9 meters. So for trial 1, 2, and 3, we have 3 trials. So now trial 1 is equals to 60 paces. Trial 2 is equals to 61 paces. Trial 3 is equals to 61 paces. So we can get the mean number of paces here on our second problem of mean number of paces equals to the summation of trials, or the summation of paces divided by the total number of trials. So 60 plus 61 plus 61 divided by the number of trials, which is 3, is equal to 60.61 paces. So that's our mean number of paces in this situation, and we can apply our previous pace factor, which is 0.6329 meters per pace, so that we can get the length pace. So our formula is pace factor is equals to length divided by mean number of paces. So we can equate that as length pace is equals to pace factor times mean number of paces, because we just have to multiply both sides by the mean number of paces, so that L pace will be left at the left side. So L pace is equals to pace factor times mean number of paces. So L paces, to replace our variables, so pace factor is equal to 0.6329 meter per pace times our mean number of paces in this situation, that is 60.61 paces. So our length pace, or the length of CD, is equal to 38.3980 meters. So it is not the same as the tape distance, but we can calculate for the percentage error. So percentage error is just equal to the absolute value of L tape minus L pace divided by L tape. So L tape here is our measured distance by taping, that is 38.9, and our L pace is the measuring distance by pacing. So 38.9, just replace the variables, 38.9 meters minus 38.3980 meters divided by 38.9 times 100%. So we can get the percentage error. So it's equal to 0.502 divided by 38.9 absolute value times 100%. So our percentage error is equal to 1.2905%. So it is just near.
In this experiment, the table shows every team member's pace factor and their corresponding error percentage in pacing. We can see that in the first part of the fieldwork, the students with a tape distance of 30 meters in line AB had 5 trials to get their respective paces from point AB to point BA. To ensure that their pacing is unaffected, each student has someone to record the full course of the fieldwork. Let's take for an example my pacing. I've gathered 5 number of paces from the different trials that I had. In total, I've garnered 237 paces. Divide it by the number of trials, and I have an average pace of 47.4. In order to get the pace factor, we simply divide the length, which is 30 meters, and the average pace. Now my pace factor is 0.6329 meter per pace. Each members have their own pace factor. The data indicates that there is a small difference in terms of decimals in students' pace factors. This is due to the potential impact of their height difference in gathering the pace. We should note that in this fieldwork, students of different age and height are mixed in. In the second part of the activity, an unknown distance from point CD is laid out. It will then be measured through pacing with only 3 trials from point CD to point BC. The distance then was found to be 39.8 meters long. Using the pace factor from the first section of the activity, students were able to compute the length pace. Let's say my pace factor earlier was 0.6329 meter per pace multiplied to the number of paces that I have in the second activity, which is an average of 60.61 paces. Then we have a length pace of 38.3980 meters. To get the error percentage, we just have to subtract the length tape to the length pace. Then divide the difference to the length tape multiplied to 100%. And then we can get an error percentage of 1.2905%. The data indicates that the estimated error for the unknown distance is close to the actual value. Therefore, we can say that pacing is a reliable method in getting the distance. However, small errors are possible to happen.